right, so our next topic in this new chapter is derivations of exponential functions. More specifically, we're looking at the natural number that we talked about before, Euler, about 2.71, 2.72. And there's the theorem 511, which we're going to use heavily in this particular section, deals with the fact that the derivative of e to the x is e to the x, but if you have the derivative of e to the u, is going to be e to the u times the derivative of u with respect to x. Now you think, well, why are they different? Well, technically they're not, because the this is actually e to the x times the derivative of x with respect to x. Well, the derivative of x with respect to x is 1. dx over dx is 1. So that's why it looks different, but they're actually the same thing. The fact that we have something other than just plain x allows us to do the appropriate derivation of that value of the exponent that we describe as u. Okay? So, let's take a look at some problems here that we are going to be dealing with here on page 357. We do some odd number problems and give you a chance to see how this works. The first one, we're asked to find the derivation of f of x, and that is equal to e to the 2x. So our chain rule we're going to use here, the u, we're going to replace the 2x with u, and then the derivative of 2x is just 2. So that means then, according to that theorem 511, number 2, e to the u du is what we're going to get from this. Well, we said that means then that u is 2x, that becomes e to the 2x, and the derivative of u is 2, so the answer for that is 2 times e to the 2x power. Alright? Number 37, same kind of deal, only now our u is going to be the square root of x for the problem here, number 37. The derivative of that then, well, you think of this as x to the 1/2 power, so the 1/2 goes in front, we subtract 1 from 1/2, we get negative 1/2, and that eventually gives us to 1 over 2 square root x. So the derivative of y here is going to be e to the u du. Well, we said e to the u is, that e to the u becomes e to the square root of x, and then the derivative of the square root of x we said is 1 over 2 square root of x, combining them together as one fraction, e to the square root of x over 2 times the square root of x. Number 39 is a little more involved, but not really. I mean, we got to be careful when we decide to use u. Sometimes we don't need to. This is one of those situations where we start off not needing to. And what I mean by that is this. If we derive this as, and pretend like this is a u here if you want to, but you don't have to deal with the inside of this till we get the major picture done. And that is, when you take the derivative of something like this, you take this to the 3rd power, which is going to be that 3 comes down here, subtract 1 from that to get 2, and we leave this on the inside alone, times the derivative of what's inside this parenthesis, which is what this is right here. Now, this is a good time to start using u's, but we're going to do that after we distribute the d dt to each of these. So it's d over dt times e to the negative t power, plus d over dt times e to the positive t power. And I'm going to do this in 2 stages. I'm going to do first this one right here. So the derivative of e to the negative t, I'm going to make u negative t, and that means du is negative 1. So as we had said, the derivative of u is going to be e to the u times du. So that means that becomes e to the negative t, and we said the derivative of u is negative 1. So that becomes a negative e to the negative t power. Do the same thing with this second part, right, this e to the t. And we said the derivative of e to the t, we're going to use u as t, and that means du is going to be 1. So this would be e to the u times du, which is e to the t times 1, plugging in the values that we have, and that gives us e to the t. So that means then the resultant derivative of this is going to be It's going to be, I don't think I meant to put an equal sign there. I think that's supposed to be a plus sign. 3 times e to the t. Oh, no, that is correct. Okay. So I just, I was thinking of another problem. All right, so basically what I did is I switched this around because we don't like negative values for the first number. So we just make that a subtraction problem. And we end up with 3 times e to the negative t plus e to the t, which was the original quantity inside. And then the derivative of what we found from the two parts gave us e to the t minus e to the negative t. All right. Next one is number 41. So for that one, we have the natural log of 1 plus e to the 2x power. So I decided to go ahead and put u in for 1 plus e to the 2x. The derivative of that, well, the derivative of 1 is 0. And the derivative of e to the 2x is going to be e to the 2x times the derivative of 2x. So we could have used the u's in there, but you don't have to stop one time at using a u. You continue on to the next step doing that as well. Just make sure you plug back in before you end up with the final result. But you get 2 times e to the 2x power because the derivative of 2x is 2. So 2 times that gives us that. And that means then, so if u prime is that, then we put that on top because we know that the derivative of the natural log of u, and I probably should have put that in there, the derivative of the natural log of u, just to remind you, is u prime over u. And that's what we've done right here. So, u prime we said is 2e to the 2x. U was what we substituted here, 1 plus e to the 2x. Nothing you can do with that. You can't cancel that because these are adding. That is your final answer. Number 45 is an interesting little problem. We have here e to the x times the parenthesis sine x plus cosine x. So when we derive this, remember this is the product rule here. We take this times the derivative of this plus this times the derivative of that. So that's what we did here. So e to the x times the derivative of sine x plus cosine x will give you e to the x times the derivative of sine of x is cosine x. Derivative of cosine x is minus or negative sine x. Do the same thing over here. Derivative, we take sine of x plus cosine x times the derivative of e to the x, which we said is e to the x. Then this doesn't change inside. Now we're going to distribute both these e to the x's across their respective parentheses contents. And we get e to the x cosine x minus e to the x sine x. That gives us that right there. Then I take e to the x times sine x here and e to the x times cosine x here. And we got a negative and a positive of the same value. They will cancel out. That leaves us 2 of these e to the x cosine x. Okay? So we kind of used theorem 511 number 1 to get this value right here from that. Okay? And that's the number problems that are kind of balancing with your even number problems. So your practice problems are 36 to 42 even, and then do number 46. Have fun.